All right, these are the answers to page 54, 2 and into 19. So first one gave us an equation, x minus 2 over x squared minus 4. And then it wanted us to complete this table. I want to show you how to do that on your calculator pretty easily. So first thing you got to do is put that equation in. So I'm going to go ahead, I'm going to go alpha y equal and create a fraction. You can do this with parentheses on the top, parentheses on the bottom as well, but this is kind of a nice little trick here, and then I'll get x squared minus 4 on there. All right, and then what I wanted to do is create a table. So you should see on the top here, table set. If I go second window, what it's going to do is give me an option. I can do table two ways. I could start at a value and then change the table by a certain amount. So if I had left it here, when I go to table, it would give me a table starting at x equal to 100, and then it would change it by 5s. All right, that would be one option I could do. Okay, sorry for the shaky camera. Or I can go down here and have it ask me for either the independent or the dependent variable. I'm going to have it ask me for the x values that I want. So now when I go to table, I can actually type in these x values and it'll give me the y values that go with them. So when I type in 1.9, it gives me 0.256, I'll say. We'll round it. All right, when I go 1.99, it gives me 0.25251 if I round it. Okay? If I type in 1.999, it gives me 0.250 now. Okay? And you can kind of see that we're starting to narrow in on just 0.25, right? If I come from the other side, if I try 2.1, I get 0.244. If I do 2.01, I get 0.249, and if I do 2.001, now I get 2.50 again. So I'm getting closer and closer to that value, 0.25. So if we had to guess from the table what this limit would be, we would say this limit is 0.25. Okay. Now we could do more than that to kind of prove it, but that's, I think, the best guess off of a table. All right. So same thing with number 5. We're going to go to y equal, and I'm going to put this in. So up top, up top, clear that out. I'm going to have, now again, I can go alpha trace. I make another fraction, 1 over x plus 1. All right, and then minus fraction 1/4. All right, and then on the bottom, we're going to have x minus 3. So let me get over here and go to the bottom, clear that out, x minus 3. All right, so this is the equation we're working with. And again, I'm going to go to table. This time I'm going to clear these out. So I'm just going to hit delete on these. All right, delete. And we're going to type in our new ones now. So I want to see what's going on when x is 2.9. So if I type in 2.9, I get a y value of negative 0.064. If I type in 2.99, I get negative 0.063. If I type in 0.299, I get negative 0.625. Okay? Then if I come from the right side, 3.1, I get negative 0.0061. 3.01 gives me negative 0.062, and then 3.001. And so you can see how from the left side, from the right side, we're really converging onto a value of negative 0.0625. Sorry, this decimal point should be right there. All right. And so we would say that that's our limit, because that's what it appears that we're approaching from the left and the right. Okay? So when you get a table like that, that's kind of, again, I don't know what else you would think it would be, but that's how we do these tables here. So now we're going to look at the graph. For number 10, it said, what does this x squared plus 2 look like as x approaches 1? If you were to put 1 in, 1 squared plus 2 is 3. And sure enough, that's what this function looks like. From the left and the right, it both looks like we're approaching a value of 3. Okay. For number 12, as we approach 1 from the left and the right, it looks like we should be equal to 3. All right, which looks like we should be a value 3. The function actually equals 1, but the limit is always what it appears to be. What does it look like it should equal? And what it looks like it should equal is 3. So that's our limit. We would say the limit of this function as x approaches 1 is 3. Same thing here. As I approach 3 from the left and from the right, I'm now going off. One's going down to negative infinity. One goes up to positive infinity. We have what's called a vertical asymptote here. All right, and we'll talk more about that later this chapter, but because we have this large disruption in the graph, we would say that this function does not have a limit. The limit does not exist. All right, because what the limit is saying, what does the function look like it equals, and it doesn't look like it equals anything, not at that spot at least. Okay. For number 15, we're saying what does the sine of pi x look like as I approach 1? As I approach 1 from the left and the right, we're converging to a spot right on the x-axis, so I would say that the limit for that is 0. For 16, we're asking what about secant x as x approaches 0? And so for that one, if I come from the left, from the right, both of them are hitting this value of 1. So we would say that this limit is 1. That's what it appears to be. It's okay that it actually is. Like 99% of the time, that's what is true, that your limit and your function are exactly the same thing. So that's okay that it doesn't have to be an open circle like in some cases we talked about earlier today. All right. On this one, we've got a little goofy stuff going on. The cosine 1 over x is oscillating back and forth. It's never ever coming to rest on anything. The closer you get to 0, you see it. It's this kind of a weird phenomenon where it just continues to go back and forth between 1 and negative 1. So because of that, again, this is not a usual one. It's kind of an unusual case, but we would say that it does not have a limit. It's not coming to rest on any one thing. When I take tangent's graph and look at it at pi over 2, again, I see that I have this vertical asymptote at pi over 2. So from the left and the right, we do not have agreement. We're not coming to a value, so we would say that that limit does not exist. And then for 19, now we have this graph here, and we're trying to make sure we clearly understand the difference between a function and its limit. So f of 1, if I go to 1, that's where the dot is, and the dot is at 2, so f of 1 is 2. But the limit says, well, what does the function look like it equals? You know, like as you come from the left and the right, where does it seem to be going? Now, problem is from the left, we're going to a value of 3 or a little above. From the right, we're going to a value of 1. We have a break, a jump in the graph. And because we have that disagreement, we would say we do not have a limit. It does not exist. Okay? When I ask for f of 4, I go to 4 and I'm looking for the dot. And I can look up and down all day long. I'm not going to find a dot there. There is no function value at 4, so we would say f of 4 is undefined. Again, we got to be real clear. Limits do not exist. Functions are not defined. And we can't mix those two around. Okay? But what does the function look like it equals? If you look at f of x from as you go to 4, it sure does look like it's right there at that value of 2. So we would say that's the limit of the function. Even though it doesn't have a value at 2 or at 4, it sure does look like that value is 2, and so that's its limit.